Hello and welcome. Today in this video we're going to be talking about applying reinforcement to concrete ramps, specifically ramps that were created with the spiral beam tool. We'll be using a variety of rebar tools and some from the Tekla warehouse that we'll discuss as we move forward. So why don't we go ahead and jump right in to applying reinforcement to concrete spiral beams or ramps. Okay, this particular ramp that we're going to be using in our example is a spiral ramp or part of a helix, either less than or over one revolution around. It was created using the concrete ribbon underneath the beam drop down using the spiral beam tool. You can come and look at the tooltip here, hit Control F to see more documentation on that tool's use. We're going to be talking about how we're going to populate both the crossing bars within this concrete piece as well as the longitudinal ones that follow the curvature of the helix. The first is somewhat straightforward. The second is a bit more difficult and requires a bit of manual modeling of single individual bars. We have some tools that can help expedite that, but at the end of the day, users may find themselves editing many points in order to make sure their configuration is correct. So let's start off with the easy stuff. Let's do the crossing bars inside here. And before I do, I just want to point out I'm using a radial grid with my ramp here. Now, you can have more than one grid in a model. You can create them from the edit ribbon, both the rectangular and radial grids. I create this one because it mimics the dimensions, both the outside, middle, and inside radiuses of my ramp. I have also provided azimuths at every 15 degrees. This is a really quick way for me to have a lot of clicking points around a center axis, and you may want to consider putting in a radial grid before really working with your concrete or rebar for these types of structures or any round structure. You can always delete it later if it's not part of the project, or if you have one, I would suggest starting with those parameters first for a radial grid that's on your documentation before proceeding. But now that I have that out of the way, we'll go up to the rebar ribbon, and we're going to use the tool by guidelines. So create rebars by guidelines. This is going to create a rebar set for us. You can see here in the tooltip how it's going to work. We're going to activate the tool, and we're going to come down and we're going to select a face of concrete that we wish to reinforce. Now, you're going to do this either for the underside and then the top separately or at the same time. I'm just going to do one, click the underneath, and I'm going to click the middle mouse wheel. Now, the prompt at Tekla tells me to pick points to define the primary guideline location. I'm going to snap back to plane, and I'm going to use some snapping points here. I'm going to click this outside edge. I'm going to click at one of my closer to center azimuths, and then the third point at the top. I'm in plane. I'm not selecting in different elevations. I'm not exactly centered on my middle point. We could do 5 points instead of 3 or more, and I'm going to show you the difference between the two. But at a minimum, 3, middle mouse click the wheel, and then repeat the process on the outside, middle click. And then we have some reinforcement. So let's take a look at the results that we were given. So if we select the reinforcement, you can see the guidelines there. And if we look in our properties for the rebar, we are going to do equal distribution by target spacing. So it's giving me 12-foot spacing, but as we can see here, this is a little wider than 12 inches, not 12 foot, sorry. And the reason for that is because of the number of guidelines or points that we are crossing. If I were to drag that there and drag this there, right, I can start to get a tighter spacing. So when it comes to interpreting and making sure that you have the best minimum and maximum spacing, as these will be different at either end of your ramp, I suggest creating points at each of your azimuths, which is where our grid will come in handy. This provides us with some fidelity and control and accuracy for the spacing of the bars. Make sure that you're just going ahead and dragging those center points, the round nodes there, and snapping to the edge of concrete where the radial azimuth meets. There we go. You can also change the distribution type. You can do target spacing values we have or number of reinforcing bars. We can change that to 30 and it will adjust. You have control over the rebar set as you would in other circumstances, and you can always get more granular with your nodes here. Essentially what you can see that we've done is created a boundary in plan view. If we rotate, you can see that's all on the plane, but the bars are still adhering to the concrete geometry. And that's the beauty of rebar sets. We could copy this and bring it to the top, or we could repeat the process and do the top, or we can select the piece of concrete and provide a concrete offset for rebar sets. There we go from the bottom, and if this is 6 inches, we'll do 2.5, and that should bump us up a little bit. Global. There we are. Give us more of a center mat. Now, adjust your depth accordingly for the thickness of your concrete and the size of bar that you're using. Okay, so now let's talk about placing the longitudinal bars. Now, in the past, I have gone to the rebar ribbon, used a single bar, and very carefully picked the concrete and slowly started to click many small points to create a curved bar. When doing so, and you go all the way up after you click your shape, it places a bar for you. But now, I must make sure that these points align with the edge of the concrete. I must account and manually model splices, and you can do that sort of thing by manipulating the offsets inside the properties pane for the single bar. However, as opposed to stepping through that tedious practice, there is a component in the warehouse that helps us do this more quickly, so that if you do need to make manual adjustments, that's what you're spending your time in and not actually creating every single bar. And so I'm going to delete that and show you a specific tool that I think will help. Snap to plane here. Okay, so specifically speaking, I am talking about a tool called concrete bridge reinforcement. It's found on the warehouse. You can see it here. Just search for this term. It provides 3 tools. So download it. It's a T-step. Activate the installer from your hard drive. Make sure Tekla is closed, or if it's open, run the installer, close Tekla, and it'll install. And you'll get these 3 toolbars. We did not use the crossing bars for our crossing bars that we modeled because the rebar sets do just fine, so there's no need for a component. But the main bars are going to help us get reinforcement that kind of comes and plays with our curvature. It's meant for bridge work, but I think in this case it's going to help us out. So remember, concrete bridge reinforcement from the Tekla warehouse, and then CIP main bars is the one we're going to want to use. So if I minimize that and then come to my applications and components side pane, I'm going to search for main bars. There we are. So it's this guy, and we're going to use this tool. If I double click on the icon, it brings up the dialog box. We have the ability to control some parameters. So the top part here is the same stuff you're going to see in the properties pane for any reinforcement you're going to create. So it's your prefix, your starting number, your bar size and type. There we go. Its name, as well as class. You change it to something else. We'll do like 5 or something. Now down below, cutting refers to how it's going to start and stop the bars and how bars will splice together. So the first bar length is the bar from where you establish your starting point, how long that bar is. It can be your full stock length or half your stock length or whatever it may be. I'm going to show you with a half there. So we're going to do 15 foot. The full bar length, we'll go ahead and do 30 foot for conversational purposes. The splice length, we're going to do 2'3" for our number, should be number 5. All right, so there's a couple of other options. Use splice object. We're going to hit no. The bars that we're creating here aren't going to be using any splice objects. The tool will do the heavy lifting for us. Allow clashes in splices. We're going to change that to no. That allows bars to overlap with one another as opposed to being spliced visually or correctly. The last one, same length for parallel bars. I start off with this no. If I get the result I like, great. If not, I come and I turn this on and see what I get for the result. So I'm going to apply those, and then with the tool active, if not, double click on it or click on it, and then come down and pick your concrete. So select part for determining bar range. We're going to pick our concrete, and we're going to go ahead and say pick the range. So we're not picking the shape, but the range, but it's the same input as we did for our crossing bars. So that corner, to that corner. Now, on the Groups tab, it's providing an offset in the positive, so I'm doing the bottom first, but you could do it from the top as well. The next point here, it says pick 2 points to determine the bar location. That means its direction. Which way are they traveling? So you don't have to pick a distance that's far. You don't have to pick a distance that's far, just a little bit. Does not have to align at all with the ramp. I'm snapping perpendicularly and giving the tool a second to think. It may ask you to pick another part after you've completed that task. Just hit the middle mouse wheel and it'll go ahead and populate those reinforcing bars for us. So that's the initial result. Let's talk about what we've got here. So you'll notice a couple of things. First and foremost, we have large spacing. Maybe that's adequate. If not, we can control that from the creation method. We can do either exact equal number of bars or by spacing, and you can change the number of bars if you wish by selecting it and then hitting modify. So it gives you a more dynamic range or closer spacing. You can see the splice zones being applied there for us, which is great. But we have, you may notice at some point on the outside where you have a bar that shows up as a single line and not necessarily a solid bar, right? And this is the result of the bending radius being compounded by the tool because of its offset. And I'll show you how to fix that really quick. But by and large, what you should do is apply the tool and inspect your result. Come in and play around with the options to tweak the specific and get as close to your configuration as you can if it doesn't give you it 100%. Some things that you may want to continue to adjust are, your bottom offset. So our start cover is just shy of an inch. If we do 2.5 and then hit modify, that was the wrong field. Let's change those to 1. The bottom cover, 2.5 inches. There we are, and that puts us in the middle of our bar, right? So we have, I think, let's see, 3.125. There you go. Not too bad. Now you can repeat this process if you want a top and a bottom mat, or you can do this as a center mat, kind of like what we're doing now. But there we are. But we want to get it as close as possible. And then I think what I'm going to do is explode the component. So now that I've used this, what I would do, once you find what works for you, what got you closest, is just go ahead and give it a save. So my ramp settings and hit save. That way you can load up and reapply and redo this very quickly if you make a mistake or want to go a different direction afterwards. And then go ahead and close that. Now I'll select those bars. I'll right click, explode component, and that's going to give me individual bars. Why did I do this? Well, we need to make some adjustments, particularly for these outside bars. And if I make those adjustments to the bars while they're still part of the component, and then I use the component to apply a change, it overwrites my changes. So that's why I had a save in case we need to go back and reapply. But I'm going to come to the properties here of these two bars that are looking a little funky. And I've noticed that the bending radius is quite large. I'm going to come and set it back to its standard, and that should correct any representational issues. I'm not quite sure exactly why that happens. I just know it does. The other thing that you can do is now with these bars, you can choose to extend them at the ends. You can select one or more and come in and start to play with the leg lengths and start and end cover thicknesses as such. So for the start cover, if we did -36, we could kick those bars out. You get the idea. If you need to adjust the position, well, you may need to come and add a point or add additional bars, but that should kind of help you kick that out just a little bit there. By and large, that's the way you're going to quickly put in this longitudinal reinforcement for a ramp or a helix or something to that effect. The reality of it is there's no copy offset, right? So, this splicing and these placement, these are all different click points to create the curved shape of the bar. So as a user, if you were to model this completely manually, I would create construction circles at every space that a bar would exist, both where the bar is and then an offset for where the the splice bar would be. You can do that again from the edit ribbon, construction object, circle. There is copy with offset for construction objects, so you can provide that offset. You're going to have to do, center to center offset for the bar diameter, and it becomes very, very tedious. So this tool kind of expedites that process for you. Even if you delete all this because you made a mistake and redo what we've just done, it's still probably faster. The last tip I'll give with this is that once you create these bars, you select them and you inquire, Tekla initially is going to not be able to recognize that shape. It's going to be an unknown. So if you're deflecting these bars, if these are just straight bars that you're deflecting, it's really actually a simple fix. You can just select them. We'll just do the first set here, not the actual splice. And we'll come over to the properties pane, and then under user-defined attributes, we're going to go to shape recognition. And there's an override here, recognize as straight bar. Select that to yes, hit modify, close the dialog. Now if we just inquire one of these bars, it shows up as straight. Now, if it needs to be something else, like a 9 or something like that, you're going to have to modify some of the rebar shape recognition rules in order to get this to work. If you need assistance with that, you can check the TUA for Rebar Shape Manager, or you can reach out to our support team for assistance on getting an existingly modeled bar that shows up as unknown to be recognized. But make sure you model the bar first and share the model with the support team. So I hope this helps and provides you with a direction to go forward. I know that it's less than the perfect process, but it does get you there fairly quickly, even if this is considered more manual. This concludes our video. Thank you for watching. Want to learn more about this topic or how to get started with Tekla Structures? Just check out the video's description for links to our user assistance page and user resources guide.